welcome to a new lecture about GitOps and Argo CD. Today we will learn what is GitOps, understand how Argo CD works, install and configure Argo CD on a Kubernetes cluster, and finally a Deno JS application deployed to Kubernetes cluster using Argo CD and GitHub. So let's get started. The main idea of GitOps is to shift focus from the infrastructure to the Git repo. Basically, this means that when you want to deploy a new application or configure an existing one, you should work with Git, not with servers. Just prepare change, create a pull request, pass the review process, merge, and boom! GitOps magic happen. There are two ways to implement the deployment strategy for GitOps: push-based and pull-based deployments. The difference between the two deployment types is how to ensure that the deployment environment actually resembles to the desired state infrastructure. When possible, the pull-based approach should be preferred as they considered the more secure and this better practice to implement GitOps. Let's get started by the push-based deployment. The push-based deployment strategy is implemented by popular CI/CD tools such as Jenkins, Circle CI, or Travis CI. The source code of the application lives inside application repository, along with Kubernetes YAML needs to deploy the application. Whenever the application code is updated, the build pipeline is triggered by a trigger or a webhooks, which builds the container image, and finally the environment configuration repository is updated with a new deployment descriptor. You can also just store template of the YAMLs in the application repository. When a new version is built, the template can be used to generate the YAML in the environment configuration repository that will be triggered to deploy a new version of our application or the desired state of our application. Let's move quickly to speak about the second strategy, is the pull-based deployment strategy. Use the same concept as the push-based variant but differ it how the deployment pipeline works. Traditional CI/CD pipeline are triggered by an external event. For example, when a new code is pushed to an application repository. With the pull-based deployment approach, the operator introduces its take the role of the pipeline by continuously comparing the desired state in the environment repository with the actual state in the deployment infrastructure. If there are a difference between the application deployed and the desired state in the environment repository, the operator updates the infrastructure to match the environment repository. Additionally, the image registry can be monitored to find the new version of image to deploy. In this case, we will learn Argo CD. It's an example of the pull-based deployment. So let's go to the next step, understand the architecture of Argo CD. Let's suppose that we want to deploy a Deno application to our Kubernetes cluster. So we have a code source of our applications, Kubernetes manifests like deployment to create a deployment, config to create some config, secret to save the sensitive data, and volume claim for persistent data. So we have a list of Kubernetes file and our application code. So we need to share these folders or files with our colleague. So we need a system controller version like Git and a Git web hosting like GitHub, GitLab or Bitbucket. So users collaborate together to push code to GitHub repository and pull it. Also we have a Kubernetes cluster when we deploy our Argo CD. So Argo CD deployed and have multiple components. So the important one is Argo CD server, which is the API server. All the interaction that you do with Argo CD has to go through this API server or the Argo CD server. It's like the Kubernetes API server for Kubernetes. And we have Argo CD repo server, the repository that ensure the communication with the external repo like GitHub, GitLab or Bitbucket. Then maintain a cache of your GitHub repository, so when we have a change in our GitHub repository, repo server compare the change with what we have in our cluster. If something different, we will apply some action in our Kubernetes cluster. Also, we have a controller which is responsible for maintaining the state of the deployed resource in your Kubernetes cluster, and we have Redis for caching and Dex server. Also, when we install Argo CD, he comes with two other components like Argo CD user interface and Argo CD CLI to give the opportunity to user to communicate directly with the Argo CD and especially with Argo CD server. So if a user push or make some modification in the GitHub repository, repo server will compare the desired state deployed in the GitHub repository and the current state that we have in the cluster Kubernetes. If something different, the repo server we will apply a change and we will create the Kubernetes object like ingress, server, pod for our application, volume for persistent data, config map to save some key value data, and secret to save sensitive data. Also, Argo CD can create object in another Kubernetes cluster. This is all about the Argo CD architecture. In the next step, we will go to install and configure our Argo CD and finally create a simple demo with Deno JS. So let's go. To install Argo CD in our Kubernetes cluster is a very simple action. First of all, we need to create a namespace called Argo CD by using kubectl create namespace Argo CD. After, we need to use kubectl apply -n to specify the namespace of our Argo CD deployment, and we will add the -f to specify the file to apply. We have the list of manifests or the list of objects that we want to deploy in our Kubernetes and especially in the Argo CD namespace. So we will download this from https://github usercontent.com Argo CD project Argo CD stable manifest install.yaml, and we will apply this in our Kubernetes cluster. So as you can see here, I create a namespace called Argo CD Kubernetes get ns, and as you can see here, I have created an Argo CD. After that, we will need to deploy this object, but I deployed this object because he take a few time. So when I make this video recording, I don't need to spend a lot of time. So for that, to get the list of resources, let kubectl get deployment to check the list of deployment that we deployed in our namespace Argo CD. And as you can see here, we have 5 deployment, like Argo CD server is deployed, also Argo CD repo server, Argo CD Redis for caching, Argo CD Dex server, and Argo CD application controller to maintain the state of our Kubernetes cluster. Also, let's go to get the list of pod in our Argo CD cluster. Kubernetes get all -n Argo CD and as you can see, we have a list of pod, a list of service in our Argo CD, a list of deployment, and a list of replica set. So we have the server of Argo CD is type node port because I make a change here to access to this Argo CD server from our node. So to modify this, just go here using kubectl edit the service Argo CD -n Argo CD, click in I to modify to insert, and go down and search type equal node port, just this in the line 75. This type was type cluster IP, but I modify this to type node port, sharp save and execute. And as you can see, we have now the type is node port. We can access to our Argo CD using the user interface. Just go here, and as you can see, this is our Argo CD interface, but there are some tricks. Go to logout, but to login you need a user name admin, but the password is the name of the pod. So go back to pod and copy this Argo CD server will then password of our Argo CD interface, paste, sign in, and this is our Argo CD interface. In the next step, we will go to explain the Argo CD interface after we will create a new deployment for our Deno application. Welcome to the latest part of Argo CD. As you can see here, after login, we have 4 icons. The first icon is when we click, we can go to the list of applications that we will create for Argo CD. Here we can create a new Argo CD application, and here we can synchronize the application to ensure that the desired state that we have in the GitHub repository is the same that we have in our Kubernetes cluster. Also here we have a list of settings. We can add a repository, create a certificate, add the keys, add a cluster, create a new project, or manage accounts. As you can see, for a cluster, we have the default cluster where we deployed our Argo CD objects. So as you can see here, I have the 1.19 version of Kubernetes, and this is our Minikube cluster where I deployed Argo CD. As you can see here, I have Minikube single node when I deployed my Argo CD object. So also, let's go back to setting. We need to create a repository. The repository is the GitHub repository where we need to synchronize applications. So as you can see, here is http Radwan Deno REST API. This is my application that I pushed to the GitHub, just I copy this URL and go to Argo CD and connect repo using SSH or HTTPS. I create to this, just go to Git, repository URL, username or password if you have a private GitHub repository to ensure the communication between Argo CD and your GitHub repository. Also, go back, skip server verification and enable LFS support only for Git and just click to connect. As you can see here, our Git is successfully connected. Also go back to setting and let's go to create a new repository. Let's go to create a new application. So go here, projects, and we have a default project. So go to manage application, click to new. The name of application is Deno application. The projects, let's check Deno application, the project default. We can specify the type of synchronized policy. We have two types, manual and automatic. Manual, we will synchronize by clicking in this button sync, but automatically when we create a change, the GitHub repository create a webhooks to launch this synchronize automatically. So we need to choose the manual option and let's check the GitHub repository, GitHub, and this is our GitHub Deno REST API application. Go ahead and let's check the path of our application. When we put our Kubernetes manifest file, so as you can see is here deployment and YAML. So we need to copy this and go to the Argo CD, deployment YAML. The cluster is the default cluster and namespace. We need to create a namespace called Deno. If the namespace does not exist, you should create this namespace. Go back to Kubernetes, kubectl get ns, and as you can see I have a Deno created. So let's go back, Deno, and this the directory, I don't need this, and let's go to create, enable to create application, code unknown, description. So let's let's verify deployment YAML.file, create, and as you can see here our application, the project is default label. We don't have a list of label. This states is out of sync. That means that the states of our deployment in our Kubernetes cluster is different that we have in our Deno REST API GitHub repository. This is the name of the repository, this is the target, this is the path of our Kubernetes manifest file, like here the API service.yaml, the API for the deployment, and the ingress to make our application accessible from our Kubernetes cluster. Also this the namespace of our application. To synchronize this with the current state of our Kubernetes cluster, just go here and click to sync. We have a list of options here. For example, we can prune to delete the old version and create a new version, dry run just to make a dry run, to up only, or to force. We need to prune and synchronize. As you can see here is synchronized and the application is on processing, And as you can see here, our application is created. We have just here the service, here our deployment, and here our ingress. And as you can see, our deployment create 3 pods: the first pod, the second pod, and the third pod, because in our application we have the number of replica equal 3. Let's suppose to modify here the number of replica and make it as 1. So make a change, go here and commit the change. As you can see, our deployment is synchronized. Let's check the number of pod. kubectl get pod -n Deno, and as you can see, we have 3 pod to synchronize with our Argo CD. As you can see, when we click to refresh, the state changed to out of sync because the desired state is 1 replica, but we have 3 replica. If we click to synchronize, as you can see, some pod will deleted, like this pod, and we have only 1 pod. And as you can see, the number of pod is go to 1. If, as you can see, we have here an error related to our image, so go back here and let's make another change, and let's go here to modify the image to Nginx container pour, and let's save the data and go back to Argo CD. As you can see, we can refresh the states between our GitHub repository and our Argo CD. Refresh, and the states we will change to out of sync. That means that the desired state is different that we have in our Argo CD. So let's up diff, and as you can see, Argo CD give you beautiful interface to show the difference. As you can see, the image go from Radwana Sacra Deno Docker 0.01 to Nginx, and container pour from 8000 to 18. Okay, and let's go back and synchronize, and as you can see, the latest pod is deleted and a new pod created, and the states is working. Let's check here to our Kubernetes cluster, Kubernetes get Deno, get pod -n Deno, and let's check the output YAML. And as you can see, the pour is running in this pour, and the image is, let's check, the namespace is Deno, and the container we will have Nginx instead of Radwana Sacra Docker Deno application. This is how Deno deployed using a GitOps pull strategy using Argo CD. This is all for today. Thanks for watching. Don't forget to like and subscribe, and see you in the next lecture. Bye bye.